Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic at hand today is guided component testing, part number 3. So we have 2 other parts in this series where we discuss guided component testing and the differences and the useful tests that you may have inside the guided component test module on the tool as well. But let's think about our diagnostic tools. Little review recap, so to say. So we have scanners and we have scopes, right? So scanners, I like to think of as a really nice compass. It's going to point you in the right direction. It's going to show you where you need to look, where you need to go, but it's only showing you part of what's going on under the hood. It's really showing you the effect after the fact. So for every effect, we really need a cause, right? So in order to find that cause, that's where the scopes come into play. And scopes, depending on how you've used them in the past or if you've ever used them at all, they can be intimidating. It's just a lot of different settings. A lot of different things that you may need to understand and know in order to set them up properly. The beauty of guided component tests is it takes a lot of that out of the equation. You don't even have to worry about what voltage do I need to set it at? What time do I need to set it at? Where do I even need to plug it in on the car to make it work? Because the tool will tell you all these things and it will set up the scope for you with the guided component test. So if we think about a computer on a car, and not necessarily just a powertrain controller or body module will be the same way, ABS, etc. But any computer on the car, we got front door and we got a back door. Think of it like a house. Front door, back door. Coming in that front door is going to be all my inputs. Coolant temp sensor, NOx sensor, oxygen sensor, all of those things go into the computer. The computer then processes those inputs based on its programming as good as it can with the programming it has. So that's the other thing you got to kind of remember. It's only as good as its programming. And that's why we have these things called reflashes. So just in case they screw up in that programming, we might need to do an update to it. And that's where the reflashes come in. So it takes all that data, comes in, processes it, and then sends it out the back door and delivers it to the scan tool as PID data. So if you're only watching PID data coming out of the computer, it's that processed data. A lot of folks call that live data. It's not actually truly live. It's at least a few milliseconds old. And once again, it is that PCM's interpretation of the data that it saw coming in the front doors. So it's useful. It's good to have, but it shouldn't be the only thing you're looking at and testing when it comes to diagnosing a problem on a vehicle. So of course, anything to test on that front door, any of those input signals coming in, testing the components directly, you're going to need a tool with a scope or guided component test meter. So things like the Zeus, the Varus, the Triton, the Modus, the Vantage, any of those tools will have scope and guided component test module built in. Now, why can't I just look at the data and just be done with it? Well, if we think about it, it's all about resolution. How much resolution do I have in my data? Can I see everything that's going on at the time it's happening in order to catch maybe intermittent problems, things of that nature? So in this picture, we have the top box is going to be PID data, process data coming out the back door. on an oxygen sensor, reading oxygen sensor voltage. This box is going to be a scope hooked up to the same oxygen sensor, reading the same voltage. These two red boxes are going to show the same amount of time passed. And I think if you took a look at this, you'll agree that there is a lot more detail in this waveform than there is in this wave. And that's not, it's not really the scan tool's fault. It's more of the car's fault because of how it has to process that data. So data comes in, processes it, spits it out, comes in, process, spit it out. Every time that happens, that little round trip takes a little bit of time. We're losing that little bit of resolution every single time, right? So the difference really in between the two is going to be the sample rate. And I'm looking at this data coming in before it even gets into the computer, right? So it's coming in before it gets there. So I can actually verify the signal is good. You ever heard the phrase garbage in, garbage out too? So I got to make sure that the signal even coming into the computer is good before I can even think about considering the scan data that's coming out the back. Right? And when we're testing components for component failure, and that is generally what we're going to do is do component testing the components for a failure. It's going to generally fall into one of these three buckets, I think. So the first one is an open. So maybe I have no voltage to the component. The 5-volt power supply line, the 5 volts isn't getting there. So it's open on the way there. Or maybe the voltage makes it to the component, but it doesn't make it back from the component. So maybe it's internally has a problem, or maybe just the wiring doesn't, the signal doesn't make it all the way back to the computer in that way. So there's your opens, either out or in. Or a short, which is the other way around. So I could have excess voltage. So let's say I get two wires rubbing together inside a harness, they break through, and then I have a 12-volt shorted to a 5-volt line, and then I have like 9 or 10 volts going down that 5-volt line. So it's excess voltage. Or I could have a short to ground, which would cause insufficient voltage. So maybe the harness is rubbing on the back of a cylinder head or something like that, and it rubs through and it touches occasionally. And when it does touch that cylinder head, it pulls some of that voltage out and pulls it down to ground. So short to ground. And then we also have a resistance issue we could be fighting. So corrosion for sure, like up in my neck of the woods for sure, up in the Northeast, and the stuff they put on the roads in the winter, terrible for anything metal on a vehicle. So if I have some corrosion there, the green fuzzy stuff on the connectors, things like that, or maybe even damage. Right? So if I have a damaged wire, it's frayed, but it's still making a connection, but it's frayed. That would be high resistance in there because it doesn't have as much wire for the current to flow through. So that would increase the resistance in the circuit and make it more difficult for it to work properly. So there's our component failure. So what is guided component test anyways, and how does it help? So guided component test, to recap, gives us operations location, connector views, tech notes, and between 1 and 6 testing methods, depending on what kind of component we're looking at. By doing this, it's going to help us avoid unnecessary parts replacement because we are testing the component directly, verifying that it has indeed failed. If it has failed, then great. I can call the parts store, order a new one. I can be a lot more confident when I do that. Also, though, we need to verify that that repair actually fixed the vehicle. So after the repair is done, I need to be able to test that as well to verify that the repair is good. Overall, that will help reduce comebacks, prevent some of those common comebacks where the part wasn't the problem, it was something else. Also, in turn, is going to help prevent a loss of a customer, because what's worse than a comeback? It's a never comeback. The customer that comes in, you try to fix their car, you don't fix it right. You don't know you didn't fix it right because they decide they want to go down and try out this other mechanic over here. Maybe they'll get it right. And then they never come back, and that is a lost customer at that point. Other side of the coin, though, if we do this, it could help attract new customers. You get known as the shop in town that, hey, they're able to fix it right the first time, right? With very minimal effort, perhaps. So that'll bring in new customers, maybe. And then overall, all of this is going to help a shop's profitability. And it doesn't matter where you work in a shop, whether or not you're the technician or the owner or the secretary, whoever it is, going to help the shop's profitability. And everybody would want to work in a profitable shop because it's going to be better for everybody involved, right? So it's a big help and a big time saver especially if you're not used to testing components using a scope. So here's an example page that we have from one of these guided component tests, and we'll see it shows us how to hook up with the color-coded leads on there. So if we think about the top panel of the lab scope, we have color-coded leads there. So we got yellow, green, blue, and red and ground. So it'll say plug the yellow lead into cam signal and black to known good ground in this case. So I'd hook up yellow to pin A and black to a known good ground like the battery or the engine or something like that. It's going to tell me where to hook it up at the sensor itself. And then on many cases or most cases, we're going to have what good should be either in text, or oftentimes we'll even have a picture. If it's supposed to display some sort of a pattern, we'll have a known good picture in there as well. Also of note, newly added, might I add, just this week with the latest update that just came out. Pardon me, very dry in here. Guided component tests are going to be adding location images. So within this, we get a separate tab that says location, and they'll give you two pictures. They'll give you one with kind of an overview of the whole engine bay, or at least the general vicinity of where it is. And then they'll get you in even closer. So in this case, we're looking at an ABS module that's attached to the hydraulic unit there. This is a little closer view of what that looks like. So we can see the overall in the engine compartment there, and it's got an arrow pointing here. And then over there, we can see that there's the hydraulic unit right there. A lot of value with that. It's not on every vehicle. It's on a smattering of vehicles right now. But as we go forward, we'll be adding these to the tool as we go. So also in this update on guided component tests, we have enhanced connector images. So these images that used to be in there, they've been in there since early 90s. And the resolution of screens has changed considerably. And we discovered kind of as you're increasing the resolution of the screen that maybe those don't necessarily scale as well as we'd like. Maybe they get a little bit blurry, something like that. So we decided to revamp and redraw a lot of these images to this new, more, I don't know, it's just more crisp. It's more easy to see, higher contrast, that sort of thing. And they scale a lot better. So it's a lot easier to see what's going on with the connector now. So you can see pin 1's over there, pin 3's over there, and then it gives us all of the wire colors and whatnot there. So all good improvements, and we're going to walk through a couple of them right now as we go on the tool. Let's pop in here. Before we get too deep though into guided component tests, I also want to refresh your memory. Maybe you're not even aware of this, but I'd like to restate that within the guided component tests, we go in there before we ID a vehicle, because all this information is vehicle specific, year, make, model, engine. In the tool, as it sits, has classes built in. A lot of people say, I want more training. I want more training. Training is important. And I definitely agree that training is important. But we do have built-in training classes within the tool. We also have in this classes section, power user tests too. So if we go into power user test, maybe like the current probe tests, we're going to choose what current probe we're using. So either we have just a generic low amp probe, the original Snap-on red one, or the newer black one that we have. So that's the one I have. So we can go in there. Go into current ramp testing. It's going to give you some generalized tests. They're not vehicle specific, but generalized tests on fuel injectors, fuel pump, ignition coils, and parasitic draw, all in there. Well, also what I noticed when I was rooting around in here today is that there's a low amp probe reference manual. So it actually has the manual for the low amp probe inside the tool. So I thought that was useful. Thinking about, zero adjustment battery replacement, that's important because you know what? I always unscrew the wrong screw. And then, not being able, man, I got to put it back together and take off this other screw. I always forget which screw it is. So having that's going to be very helpful because I lost the instructions a long time ago. Having them on the tool is very helpful. Also like this with scale. So I got a phone call today from a franchisee, and they had someone who was asking about using a non-Snap-on low amp probe or a high amp probe. Actually, they're asking because they wanted to test maybe a starter draw with higher amperage than the low amp probe would cover. The low amp probe goes up to about 60. If it sees more than 60, it kind of maybe flat spots or whatever. It's not going to read it correct. So I said, yeah, you can definitely use a high amp probe. We have them in the catalog as well. But you just need to note the output voltage of it. So in this case, on this, at the 20 amp scale on the Snap-on low amp probe, it will output 100 millivolts for every amp that it reads. So it'd be 50 millivolts if it was half an amp, 200 millivolts for 2 amps, and so on. So I said, you're not going to be able to use it on the amp probe setting if you use this other clamp, but they can set it to voltage, and then they'll just have to know, what equates to an amp. So if it's 100 millivolts an amp or 150 millivolts an amp or whatever it is, they just would have to do the math. So you can use other low amp probes or high amp probes or whatever with the tool. As long as the banana jacks plug in, it'll still work. But you just need to know you might need to use it in a different way. I wouldn't set it up for an amp probe. I would set it up as a voltage probe and then just do the math. So I thought that was interesting how they have this little bit on voltage conversion in there. That's pretty good. Pretty good little thing in there to keep in mind and remember. Also in here, pressure transducer tests. So you can go in there and do like line pressure, exhaust back pressure, fuel pressure and fuel pump current, that sort of thing. All preset in there just kind of as a general test. But the bulk of this information is going to be under how-to right here. So as we can see, it's everything from 10-minute basic electronic component classes all the way down to a 30-minute electronically controlled transmission class. There's also some general tests, no start basics, automotive theory, theory and operation, test tips, current ramp classes, CAN bus class, automotive electrics class, waveform class, 65 different categories in all as to what's in here. And then inside these classes, that was a bad example, but inside these classes, inside the categories, there are a multitude of classes inside. So inside 10-minute electronics classes, we got 2, 4, 6, 8, 10 different classes on like Ohm's law, scientific notation, resistance, that sort of thing. So there is a wealth of information in here before I even get to the actual vehicle specific testing. So that is pretty key to remember. So let's go in here and look at a couple different vehicles. So the first one I want to do is these location information, right? So if I go in there, I'm going to pull up this 15 Legacy. And you see we have, let me back up here for a second. So when you ID a vehicle, like I said, year, make, model, engine, you're going to get in, and the first thing we're going to see is all of the different systems that we have information to test. So in this case, you have 1, 2, 3, 4, 5, 6, 7, 8 different systems that we have information on. In this case, I want to go in the engine. Once you're in a system, it's going to list a group of components or maybe even subsystems like the fuel system that you could go in here. So if I wanted to look at, say, like the fuel injector or something like that, I have tests that I can run on the fuel injector. But in this case, what I want is I want one of those locator images. So in this case, let's say I wanted to find where's the oil temperature sensor on this car. So let's find where that is, because maybe you don't work on the same cars every day, and you don't necessarily know where everything is. So we're going to go in here, and we have a location image tab here. And when we do that, you can see there's my overview of the engine bay, and it's pointing at this oil filter right here. And the oil filter is underneath the oil filter. We have the oil temperature sensor right there. So then we could then go in, back up here, and we could do like a DC voltage test if we wanted to do the voltage test, right? Hit view meter. The other nice thing it is when you go into the meter, it is going to set up the voltage for you and set up the time for you and set up the trigger for you all automatically. So I'm using a scope to test components. Not necessarily, though. I take that back. You're not always using a scope in here either. The tool will select whatever the appropriate meter type is too. So if I need to do resistance, it will pull out, for example, if I do resistance here and I hit view meter, it's going to pull, you can't really see it, but it's going to pull out an ohm meter. If I need to check something that a graphing multimeter would be more appropriate, it'll pull up a graphing multimeter. Or if it needs a full scope, it'll pull up the scope as well. So it's going to depend on what we're testing and how we're testing it. It will pull up the appropriate meter and set up the voltage and set up the time and tell you where to hook up and tell you where to plug in. All that information all in one place right on that screen it just makes life so much easier when you're trying to test parts, because this is all information you're going to need to look up elsewhere if you're using some other way of doing it. So it's going to just save you time in general. Doesn't matter how good of a scope user you are. Maybe you're a beginner, maybe you're super advanced. It's going to save you time because it does most of the work for you. Next one I wanted to talk about was the connector views. So we're going to pull up this vehicle we had earlier in the slide presentation there. And you'll see it's a 96 Honda Passport. Going to engine, you can see we have a multitude of sensors in here. I think crank sensor might have one. There we go. So if I go into the crank sensor, for example, on a signature test, this is going to give me a known good crank sensor pattern. And it's going to give me those new, larger, easier to see connector views. And then it tells you what each of those does. So what color is the wire, etc. So it's going to show you what it's supposed to look like right there on the tool. It's going to save you. That saves you a ton of time right there. And the new connectors aren't on everything either. Like I said earlier, that would be a gargantuan task to be able to do all of that in just 6 months. So we're picking away at it as we go. As we do more updates, everything will get more updated. Next one I want to talk about. This was a big add here as well in the latest software update. So in the guided component test, we have a whole new system in here for electric vehicles, hybrid vehicles, things of that nature, is HV electronics for high voltage electronics. If we go in there, you can see we have things like that, the engine cooling fans, high voltage coolant temp sensor, right? So we have the coolant temp sensor. It's going to tell us how it works. That's got the new connector in there as well. Quick charge port. Can do a resistance test on the charging port, right? It's going to tell you all of that. So there's my charger right there, is my pin assignment. It's going to tell us all about how it works and how we're going to test it. So that's a lot of information in there. I think that's a considerable amount. It also tells you your warnings. So make sure you remove the service plug. Be sure to wear insulating protective equipment, gloves, shoes, face shield, etc. You do want to be very careful when it comes to working on high voltage anywhere, high voltage anywhere. Things like the service plug, right? So here's where the service plug is, and here's why you want to take it out, that sort of thing. So a lot of information, 1, 2, 3, 4, 5, 20 different components that we can test inside that, or 19, I guess, because we have abbreviations. So the rest of these can be tested, or at least there's information on them. So even the traction motor, right? We can go in there, we can look, traction motor resolvers, and that is a 3-phase motor as well. So lots of good information on those, lots of good information. And then another one I want to talk about is this one right here. So BMW 330i in this case. So for this latest release, BMW, couple BMWs, couple Mercedes, couple Mini vehicles have brushless fuel pump tests in here. So we go under engine, and then we go under fuel system, and we go to fuel pump. We will see that there are a few different tests in here. If we go into component information, it's going to tell us how it works. So the electronic fuel pump is a 3-phase brushless motor. The ECM controls the fuel pump via pulse width modulated signal from the engine control module. Let's see, fuel pump electronics activates the 3-phase motor. The pulse width modulated signal is also used for diagnosis of the fuel pump control electronics. 3 phases operate the fuel pump are as follows: phase U, phase V, and phase W. Each phase is pulsed for 120 degrees of rotation. If we go down, it's going to give us many different connector views. The system does not use the fuel pump relay. The fuel pump is controlled with its operating voltage from the fuel pump control electronics, which receives its signal from the ECM. Fuel pump control electronics activates the brushless 3-phase motor. Fuel pump control electronics is not a control module and is not the same as the EKPS module. Warning, do not attempt to activate this brushless 3-phase fuel pump with system voltage or the pump will be damaged. So don't take your power probe it in there, and try to make the thing run. It's going to damage the pump. It doesn't work the same way a brushed normal fuel pump works. So just be aware of that. And if I go into current ramp test, this has got some interesting information in here as well. So it's going to tell us how to hook it up. If you have a 4-channel scope, you can actually look at all 3 channels, as well as adding another for a low amp probe. So here's a few different examples down here on the bottom as to what each does. So we can see how the current goes up when it's positive and it comes down when it's negative. So there's positive and negative current flow on these pumps as well. So we can actually see how they go up and down. Each called UV and W, pulse for 120 degrees, which gives you 360 degrees. So this is a new test that was added in on, like I said, some BMW, some Mercedes, and some Minis on this. There are other vehicles that use this, and I'm sure over time they'll get added in for those vehicles as well. So a lot of good new information, a lot of good new updates to this guided component test. If you haven't gone in and checked out guided component test and you have a tool that has it, you don't have to hook up to a car to do it. You can just go through and look at all the different tests. Look up your own car. There's over 5 million tests inside the guided component test module. Goes all the way back to 1981. So there are things in there. Let's see. Caddy goes back to 81, right? So I can go into a like a Fleetwood Brougham, right? I can plug into that and look at the that awesome 4.1 engine, right? So you got a carbureted engine, and we can still look at, if you want to look up the barrel sensor on that. Now here's what it looks like. 3-wire sensor changes voltage signal to PCM with altitude change. Simple enough. You know, EGR, HEI pickup coils, knock sensor, right? All of these different things. You can still test them. The vacuum switch is still tested on that, right? So we've been putting these in here since the 90s. So we go way, way back. It is a huge database of information. Anything you would want to look up on pretty much most manufacturers that we cover is going to be in there. So definitely worth another look if you haven't looked in a while, especially with the new update and all those new improvements that are available on it as well. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully, we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.